Okay, here is the answer key in video form. I'll do a distant shot here, so if you want to pause it, you can kind of look at the whole thing. Um, it's just faster to do it this way where it's already written out. The 5 points of the quadratic function, the key thing here is exact terms, okay? You can put this on your calculator and you can zoom and trace and find a lot of it, but you will not find those exact values. First step is you must know minus b over 2a. That's a basic way of finding the vertex of any parabola. You can find that by just taking the opposite of the b value, twice the a value, make a fraction. That's your axis of symmetry, which I did not sketch in here. See if I can do that here with one hand on the camera. So there's your axis of symmetry at x equals 1. Okay, so do sketch that in. And then plug in that value of 1 into the function. So f of 1, I work it out here, is negative 14. Then you plug in 0, you get negative 13, that's just your c value. And then you can flip that over using the symmetry line, and you get a second point, or a third point rather, really easily. And then you find the other 2 points by just plugging a, b, and c into the quadratic formula, or you can factor it, but factoring only works when that's a nice number. If that was 15, 3 and 5 give you 15 when you multiply and subtract to make 2, but 13 ain't going to happen. So when you plug it into the quadratic formula, it works out to be 1 plus or minus the square root of 14. Okay? And that's the exact value. All right? So it means you have to know some math smarts, not just calculator skills. All right? So this is a rational function. The steps are pretty clearly here. Definitely want to simplify. And simplify means factoring and then canceling. If you're canceling a number, you're not going to have any big deal. But if you cancel a variable, you're going to get what's called a removable discontinuity. All right. In this case, if you factor the top and you can take out a 4x and you get x plus 1, that is definitely a value you're going to want to check down here. The way you check to see if there are zeros and things that are factorable is put just the denominator. Just type in x cubed minus x, or plus x squared. Put that into your calculator. Look at that cubic function. Look at the zeros. One of them will be a negative 1. And then the opposite of negative 1 will give you the factor of x plus 1. Okay, that's an important thing to know from this unit, that the 0 there is the negative 1. So you got to think about the opposite of that when you write that. Okay. Then I did some polynomial long division here. Okay. It's a little bit different because it works out evenly. You wind up with 0. So you simply bring down the next two values and keep going, and it factors out to be this. All right. If you're not sure, just do the multiplication. Just FOIL that out, and you'll see that you will indeed get this thing that you started with. All right. So a nice thing about math is you can check your work. Then when you factor that out, these guys cancel, and that is going to give you what we'll see is called removable discontinuity. When you solve this and set this equal to 0, you can just do a little equation here, and lo and behold, it's just the square root of 24. Just so you know where to plot the points, it's plus or minus 4.9 or thereabout, but that's the exact value, all right? And I've labeled the asymptotes then. This is where you get 0, so that's where those dotted lines are. It would be easy to think that they're at like plus or minus 5, but it's really a little bit less. Then look at that battle of the exponents in the numerator and the denominator. You can do it here as well. The denominator is bigger. So something that is big and blowing up to infinity in the denominator, when the top stays smaller, is going to go to 0. So the horizontal asymptote is 0. I didn't write that down, but it's equal to 0. And here the horizontal asymptotes are the plus or minus radical 24. Okay. Then as far as looking at your calculator, I have that somewhere. Here it is. Type that in. Just make sure you type it super carefully. This is an old school calculator, so it doesn't do the exponents quite the same as some of yours, but just again, use parentheses. Make sure you haven't forgotten anything. Common thing to do is to leave out x's or leave out the exponents. But then you're going to get something like that. And if you did not take out that removable discontinuity, you'd expect to see an asymptote there where this thing curves up or loops down or something, and if you zoom in, it doesn't do that. So hopefully that will give you a clue that it is something you factored out, because it looks like it really only has the 2 zeros. This will help you see that the horizontal asymptote is 0. Be careful, because sometimes they can be close to 0, right? If this had been equal degree and that was like 4 over 5, it might be some fraction that's close to 0 but isn't. Then here you've got the range. There is a y value that will appear everywhere. There's no gaps, okay? If there is a gap, you just want to carefully say what that gap is, maybe in the middle. In this case, there is none, so it's all real numbers. X values can be anything except for, oops, I didn't write it down. It should be plus or minus radical 24 and 0, okay? Right there, what's the domain? And 0 also, okay? You cannot plug in 0 into the original formula because you get division by, oops, sorry, 1, negative 1, negative 1, that's my third offer, negative 1, okay, because that's going to give me division by 0, negative 1 left, all right? Then the removable discontinuity, you go to negative 1 and you just make a circle there, and then label it RD. That stands for removable discontinuity, something you factored out, all right? That is it, all the bells and whistles. It will definitely not be any harder than that, probably quite a bit easier. Good luck.